Let's begin. Hey everyone, I'm Avinash. So I do important legal questions on YouTube. So before I begin, I always put the link to the code which I have typed in the description, so you can find that on my GitHub page. So today I picked the top K frequent elements question. So it's one of the frequent questions asked by Facebook. It's been asked by Facebook 19 times. Facebook, Amazon, and Google, Apple as well. Okay. Uh, so the question is, so you're given a non-empty array of integers and you have to return the k most frequent elements. For example, here in this nums array, uh, 1 has a frequency of 3, 2 has a frequency of 2, and 3 has a frequency of 1. So they're asking for the two most frequent elements. So that's why we have written 1 and 2. Yes. Uh, okay, so let's begin coding. Uh, and we have, okay, before that, just a second. So we have this constraint that the time complexity must be better than big O and log n. Okay, so you should know that for a standard sorting algorithm, the time complexity is big O and log n. So you have to get a better answer than just sorting it. And they have also mentioned that it's guaranteed the answer is unique. That means, uh, other words, in other words, okay, the set of top k frequent elements is unique. Okay, that's a good condition to know. So, like, we can begin by writing a base check or an edge case. So it is if k is equal to nums dot length, then you return nums. So that is because if they're asking for like k frequent elements and the length is equal to the length of the nums array, so by the statement nums would be the answer. Okay, so I'm going to need a hash map, which is going to have an integer with an integer. Let me call it maps. So new hash map. Okay. The reason I need a hash map is I'm trying to count the frequency of each integer in the nums array, and I'm going to store it in the map. So let's iterate over for integer number in nums. I'm going to say map dot put of the number with map dot get or default dfa f get or default of the number comma 0 plus 1. Okay, so what I'm trying to do is I'm going to put the number with, so each time I find, okay, the first time I'm going to find the number, so I'm going to put the number, since the number is not existing in my map, so it will pick the default to 0 and it is going to add 1 to that. So the first time I encounter a number, it's going to put the number with frequency 1. The second time I encounter the same number, this time it's going to get that number. So previously, if the frequency of that number was 1, so I'm going to add the number value, that is 1 plus 1, I'm going to put 2 into my map. Okay, then I'm going to need a priority queue, where I'm going to store integer. Let me call this a min heap. So since I'm going to need the top k most frequent values, that is the maximum occurring value, so I'm going to use a min heap. new priority queue. Okay, so I'm going to write a lambda function over here. So how I'm going to compare insertions of A and B is that uh, I'm going to compare it on the map's value. That is, so each hash map has a key value pair. So I'm going to compare the value based on the value in the map. So I'm going to get number A minus map dot get of B. So this would give me a min heap, which means the minimum element will be on the top, and that is the minimum frequent element will be on the top of the heap, and the most frequent element will be in the bottom. I'll explain the reason I'm going to choose a min heap. So I'm going to iterate over integer number n map dot key set. So this function is going to give me all the keys in my hash map. So I'm going to say min heap dot add of that number, and if the min heap dot size is greater than k, then I'm going to say min heap dot poll. Okay, so basically what we are doing is, uh, if suppose for this example here, uh, we have one with frequency 3, then two with frequency 2, and three with frequency 1. So I'm going to add all these keys to my min heap. So hashmap does not have any ordering, so it can come in any random order. So I'm going to add all of them. So each time my min heap size reaches k, I'm going to the remove the head. So Paul is going to remove the head of the heap. So that way, I always keep only k required elements in my min heap. Also, also it's important to know uh, that in the complexity they have mentioned that it must be better than big of n log n. So why we are keeping the max size should be the min size should be less than k is, uh, if we want we could like put all the elements into the heap as well and like pick from the bottom, but that would lead to complexity of n log n. So to be like, okay, so okay, it's better that I explain this. So the time complexity to insert into a min heap is big O of log k. So k being the number of elements in the heap. So if suppose we are inserting n elements into the heap and we are iterating over it with n times, so the complexity would become n times log n. So if we keep only k elements in the loop, uh, the complexity will reduce down to big O of n log k. That is the reason we are trying to keep only k elements. Okay, I hope I explained it correctly. If not, you can like let me know in the comments. Okay, then I'm going to have an integer result. So by the end of this loop, my min heap is going to have the top k frequent elements. So now I have to form the result to return it. So by here, your problem is done. I'm just doing this to return the result. So integer of k, okay. So for integer, I is equal to k minus 1, I is greater than or equal to 0, I minus minus. Okay, so the reason I'm doing this is, uh, So they are asking for the k most frequent elements, at least in the output, in increasing order. So one is the most frequent elements, two is the second most frequent element. So if this was our input, right now our min heap will contain two at the top and one in one of its branch nodes in the heap. So that's why we form the results in the reverse order. So we are going to pick two first and put it into our result and then one. So that is why we are like starting from the end. I hope that makes it clear. So result of phi is equal to min heap dot poll. So each time it is going to pick the topmost element in the heap and it's going to assign it to the last kth element in our result array. Yep, I think that does it. All I have to do is return the result. So let me check for any errors. Dot port. Okay. Let me check. Oh, that's good. Let me submit this. Okay, that's a good solution. So I'm going to talk about the time complexity of this algorithm. So the time complexity is big of n log big of n log k. So so that is because I'm storing k elements in the heap and I'm iterating over with all the n elements in my key set. So I'm assuming that my key set is all unique. So in the worst case, it's going to be n log k, and the space complexity is, in the worst case, assuming that our nums array has all unique characters, it is going to be big O of n. Yep, that's it. So as I told before, I'm going to put the code link in the description. Please let me know if I make any mistakes or something. I'll try to correct myself. Consider subscribing. Thank you so much, guys. Have a good day.